Radical expressions and radical signs. Anytime you see the word radical, it's just referring to square roots, cube roots, fourth roots, and on and on and on. Now this symbol right here is called the radical sign. Now if you don't see a number on the outside, it's always understood to be a 2 or the square root. Later on you're going to see that there will be numbers like a 3 or 4 or 5, whatever it may be. This is called the cube root or the third root. This is called the fourth root. This is called the fifth root. By definition, this square root of a is the non-negative or principal square root of a. The number b is the square root of a if b squared equals a. In other words, what number squared gives you the number underneath. Now that a, the item, the number, the letter underneath the square root or radical sign, that's called the radicand. And so if you ever hear me use that word, that's what I'm referring to, the radicand. So let's do a few of these. Square root of 25, all it's asking you is what number squared is 25. If you know your multiplication tables, it's 5. Positive 5, we're always looking for the non-negative square root by definition. Later on, when we have variables, that will affect some things, and also by and how things are worded may change a little bit. I'm going to show you quickly how to do these with your calculator. If you have a graphing calculator, your square root button is over here, right above the x squared key, right there. So if I want to hit it, clear some things out. If I want to find the square root of 25, I'm going to do the square root symbol first, and then the 5, and then I'm just going to hit enter. I could close the parentheses, then hit enter, and you'll see the answer is 5. If you have a scientific calculator, such as one like this, you type in the number first, so hit the 25, and you look for the square root key. In this case, it's right here, so I'm going to hit that key, and that gives me 5. So that's how you do it on either calculator. Now let's do the following few problems. Negative square root of 81. By the order of operations, you do the square root before you do the negative. Square roots, or any radical, are exponents. Exponents come before subtraction. So the square root of 81 is 9, and that minus sign just comes along for the ride. So the final answer is a negative 9. Square root of 0, what do you square to get 0? Well, 0 squared is 0. Now we come to this one. What's the square root of negative 9? Now what can you square to get a negative number? There's no number. So in this case, it's the empty set, no solution. And if you type that in your graphing calculator, second square root negative 9, and by the way, the negative symbol is down here in case you're wondering. If I hit enter, it's going to tell me that it's not a real answer. Now let's do a couple more. Square root of 49 over 121. You're going to find out that all you're going to really do is find the square root of 49 on top, which is 7, and the square root of 121, which is 11. Now I'm going to show you something with the graphing calculator in case you didn't know this. Well, if I type in square root of, that was 49 over 121, 49 divided by 121, hit enter, and I get a decimal answer. Well, watch this. If I hit the math key, then frac is already lit up as 1, or if I hit enter, frac appears and hit enter again, it gives me the answer, 7 over 11. We're going to use our calculator to do the next example, the cube root of 7, or my bad, the square root of 7 to 3 decimal places. So I'm just going to type that in. Into 3 decimal places, it's 2.646. Approximately 2.646. The reason why I have to use my calculator in this one is because 7, there's no number squared that gives me 7. So I can approximate, and the calculator helps me do that. But like I said, there are other roots besides the square root. Cube root has the same rules as square roots, except we're thinking what number times itself 3 times, or what number cubed in this case gives us negative 64. Now we can have a negative number under the cube root or any odd root, because if you take a negative times itself 3 times, 5 times, 7 times, you'll get a negative number back. So in this case we're thinking what cubed is negative 64. Now if you think about it, these numbers get big really quickly. The answer is actually going to be negative 4. because if you take a negative 4 times a negative 4 times a negative 4, a negative 4 times negative 4 is 16, and 16 times negative 64 is negative 64. But you also have a calculator. So let me show you how you do a few things in your calculator. Let's look at the graphing calculator first. Cube root. First thing, if I go to the math key, this one happens to have the cube root. So if I hit 4 and then negative 64, you'll see the answer is negative 4. Now there is another way. I'm going to show you with the fourth root of 81. If you look at the math key, you won't see a fourth root, but you do see an x root. So in order to use that x root key, what we got to do first is to type in the 4 first, and then the x root, which is number 5. So now when you see that in your calculator, that 4 takes the place of the x. And when I hit the 81, I put parentheses in. Notice, see that parentheses? There's not one when I bring up the x root. There is on the square root. So I don't need it here. If I did need it, I'd put it in front and after the 81. And it gives us the answer of 3, because 3 to the 4th power is 81. Now if you have a scientific, most of these don't have cube roots or fourth roots, but they do have the x root. And so if you look, you'll eventually find it somewhere around here. And now I'm looking for it on mine. And sometimes you just gotta look. This one does have a cube root. This one, and it's probably hard to see, but that's a cube root down there. But I'm looking for the one that has the x root. And some of them may not have it. Oh, mine has it right up here. You'll see an x outside of a y in this case. It looks like this. That's how mine appears. So what I'm going to do is, I'm going to hit the 81 first, and then I'm going to hit second, and then the x root key, and then the 4, which gives me 3. So I do it backwards. Radicand first. Now on this one, when I find the fifth root of negative 1, all I'm going to do is just think what times what 5 times gives me negative 1. Well, I know 1 times itself 5 times is 1, and negative times itself 5 times is a negative, so the answer is a negative 1. Once again, you can also use your calculator and do what you got to do. Now let's look at radicals that aren't square roots. We call those nth roots. Now the number on the outside is called the index. And so if you see a 3, that's called a cube root. If you see a 4, it's called the fourth root. 5 is called the fifth root. Same principles apply as far as how you find them. For example, the cube root of negative 64. You're thinking what number cubed gives you a negative 64? Now keep in mind, you are allowed to have a negative under an odd index or odd root. Reason being is if you take a negative number times itself an odd number of times, you get a negative number back. So you're allowed to have negatives under odd indices or for odd roots. Now, if you don't know how to find the cube root of negative 64, and by the way, the answer is negative 4. The reason why it's negative 4 is if you take a negative 4 times itself 3 times, you'll get negative 4 times negative 4 is 16, and 16 times negative 4 is the negative 64. You can always use your calculator. I'm going to start the graphing calculator. Now, if you look in the math key, if you hit math, I turn it on first. If you hit the math key, you'll see the cube root. You also see an x root key. I'm going to hit the cube root, number 4. I could always also scroll down and hit enter, but I'm going to hit the 4. It's quicker. Then I type in negative 64. In case you don't know what the negative sign is, it's right down here. So I hit negative 64. I can close parentheses or not, it doesn't really matter. Then I hit enter, and it gives us the answer of a negative 4. I'm going to go ahead and do the fourth root of 81 to show you how that's done. But once again, the index is 4. You're thinking what number times itself 4 times gives you 81. The answer is a 3. If you want to know how you find that on a graphing calculator, once again, let's go to the math key. You'll notice that there is no fourth root, but beside the 5 you'll see an x root. So what that means is I'm going to hit the 4 first, and then hit math, and then I'm going to go and hit number 5 for the x root. So what you now see is 4 x root then 81. What's going on is the 4 is taking the place of the x, so the calculator sees that as fourth root of 81. You hit enter, and you see the 3. Now if you have a scientific calculator, Some of them have cube roots, some of them don't. This one happens to have a cube root above the 0. If you look above the y, the x key, you'll see an x root key. Now the x root key looks like this, in case you cannot see it. So, if I want to do the cube root of negative 64, what I'm going to do is, I'm going to hit the 64. I'm going to turn it on first. I'm going to hit, clear it out, hit 64, negative. Then I'm going to hit second 0, because that's where the cube root key is. Then it gives me the answer negative 4. I'm going to clear it out. Now let's do the fourth root of 81. This time when we hit the 81, and then above the x, I see the x root key, so we hit, and it's yellow, so I hit the yellow key first, and then I hit the 4, and I get the answer of 3. So that's how you do it on both types of calculators. Now the fifth root of negative 1, you're thinking what number times itself 5 times is negative 1? Well, since it's an odd root, I can get a negative answer. It's negative 1. You can always type it in if you don't believe me. Now let's go ahead and let's look at simplifying radicals that contain variables now. Now keep in mind we're always trying to get a positive answer when we're dealing with even roots, because we can't take the even root of a negative number. So anytime we're dealing with any real number, that means that we're dealing with potentially negative numbers. But when we're dealing with even indices or even roots, we must guarantee that we have a positive value or non-negative value, because we can also have a 0. In order to guarantee that, we must have an absolute value around the variables, or actually around the solution. So the key phrase here is when a is any real number, we got to be concerned about absolute values. If it's an odd integer, we don't care. Got that? Because we can have negatives under the odd roots. It's only when we're dealing with any real number, when a is any real number, and the index is an even number. We'll do some examples, give you an idea what's going on. But what I really want you to be concerned about is notice that the nth root of a to the n is actually equal to absolute value of a, or a. What's really going on is that the index is divided into the exponent. The n divides into the n, and those cancel out, leaving the a. We're going to do some examples to show you what's going on. I'm going to show you the shortcut, or the long way, and then the shortcut. So let's do a few of these. Now when you read this first example, it says find each square root. It actually shouldn't be each square root, it should be find each root, because we're not only going to be dealing with square roots, we're going to be dealing with cube roots and fourth roots and whatever else we really want to. So let's do a few of these. But notice in the instructions it says assume that all variables represent non-negative real numbers. So what that means is that we're assuming that the x is always 0 or any number bigger than 0. So we don't have to worry about the absolute value in this case. So when we're doing square root of x squared, first thing you realize is that square root has a number on the outside, which is a 2. And so you're thinking to yourself, what is square root of x squared? Well, what number squared gives you x squared? Well, the answer is x. There's all kinds of ways to think of it. I could use numbers to help you understand that, and I think I will. For example, the square root of 9 is the answer is 3, but did you know 9 is the same as 3 squared? And so if 9 is the same as 3 squared, and square root of 9 is 3, the square root of 3 squared is also 3. What that's basically saying is that the number exponent divides out with the index. 2 divides into 2, and it gives us a positive x, because we're assuming that the variable is already non-negative. Now let's do B part. This one may be a little bit more difficult to understand. Here's how I'm going to do it. But we're going to use the basis of the fact that the square root of x squared is x. Nth root of a to the n is a. Square root of x squared is x. What I'm going to do is I'm going to take that x to the 6th and write it out as x times x times x times x times x times x. So it's the square root of x times itself 6 times. Now what I'm going to do is I'm going to rewrite that as in pairs, because every 2x of the x's ends up being x squared. And then you're going to find out later on there's a little trick or a little property that says that each one of those x squares gets its own square root. This is a long way. Keep that in mind. And then we've already discovered that the square root of x squared is x, and I got 3 of those, so I have x times x times x. And then x times x times x is the same as x to the third, or x cubed. But there's a faster way. If it's square root, the index is a 2. How many times 2 divided by 6? 3 times. That's the way I prefer to do it. You'll find out that's by far the easiest way. So let's go with that. And on this one, it makes it a whole lot easier if you realize that there's a 2 on the outside. And so you just do each one of these terms or items in Radican individually. So in other words, what's the square root of 100? Well, that's 10. Square root of x to the 14th. How many 2's go into 14? Well, that's 7. And what's basically going on is how many x squares are there in x to the 14th, and there will be 7. That's what's really going on. How many squares are there in y to the 8th? Well, there's 4. And we're done. Now, like I said, we're not only dealing with square roots. This also can be applied to cube roots, fourth roots, or any root. So let's do a few of higher order roots. So in other words, how many cubes or x cubes are there in x to the 18th? That's like asking how many 3 are there in 18. And you would say 18 divided by 3 is 6. It's as simple as that. This one, we're going to separate it. We're going to do the top part, cube root of x to the 27th over cube root of 27. We're going to look at it separately. So how many times is 3 going to 27? 9 times. But we'll watch the cube root of 27. If you type that in, you're going to get 3. That's how you're doing. Let's look at the fourth root of y to the 12th. That's saying how many y to the 4th are there in y to the 12th? Well, there's 4 goes in 12. 3 times. That's your answer. Let's do this one. Let's do it really quickly. What's this? Fourth root of x to 32 y to the 100th over 16z to the 8th. Well, it's saying how many times 4 are going to 32? And you'll say 8. How many times 4 are going to 100? You'll say 25. How many times 4 are going to 8? And you'll say 2. Now skip the 16 on purpose. Don't miss this. Most people will say it's 4, but it's not. It's the fourth root of 16. So what number times itself 4 times is 16? That answer is 2. So there's your final answer. Now let's go ahead and finish this second example. Once again, we're not just dealing with square roots, we're dealing with any root. So, but this time, we want to assume that all variables represent any real number. So in other words, we got to guarantee that we have a positive value when we get done. Now, for this question A, you'll see that we have the square root of negative 2 squared. Now, by definition, we can say that's the same as you would think that the answer is going to be negative 2. Because the square cancels, or the 2 on the outside cancels the 2 on the inside, and it leaves a negative 2. But since we're dealing with any real number, it's the absolute value of negative 2. We got to account for the possible fact that we can get a negative radicand, or a negative number that could result if we don't use absolute values, because we're dealing with any real numbers. Real numbers include negatives. But when we're trying to find square roots or any even root, our answer must always be a positive. And so the absolute value takes care of everything. So what's the absolute value of negative 2? The answer is positive 2. That's what's going on when we're dealing with any real number. Now let's do B part. Square root of 9x squared. Now the square root of 9 is 3. And the square root of x squared is x. But we don't know if x is positive or negative, and we must guarantee that it's positive. The reason why we don't know if it's positive or negative is because the variable could be any real number, including negatives. So to guarantee that it's a positive number, that we must have it to be absolute value bars. Same thing with fourth root of x minus 1 to the 4th. We must guarantee that if we cancel the 4 with that 4, that we end up with a positive result. And the only way we can end up with a positive result is absolute value bars. Once again, that's only because we're dealing with any real numbers. The variables could be any real number, which means we could have actual negative values if we knew what x was. To guarantee that we have positive values, we use absolute value bars. Now, in D part, you'll notice it's a cube root. With the odd roots, we don't care what the variables represent, because we're allowed to have negative numbers underneath odd roots. So when we have the cube root of x plus 2 to the cube, this cube root cancels with this cube, and it leaves x plus 2, and we're done with that. So the only time we have to worry about absolute values are when we're dealing with even roots, for where the variables represent any real number. You don't see it a lot, but you see it enough to be concerned about. Now, the last thing we're going to look at, this is just an application of function values. Not that big a deal. It's pretty much saying that radical functions are the form f of x equals nth root of x. The key thing is you'll see this notation f of x. With this example, you do what you think you're going to do. We're going to take this function f of x equals the square root of x squared minus 5. And we're going to find f of 7, which means everywhere you have an x, you replace it with a 7. Key thing is to make sure you write it correctly. Now, by the order of operations, we do what's underneath the square root. Exponents come first. And for right now, when we find 49 minus 5, we get the square root of 44, and we're going to leave it like that. You can find the decimal value. It depends on what the system is asking. But for now, we're going to leave it like that. Later on, we're going to find something else to do with it. Now, let's find f of negative 3. Use the exact same function. I'm going to substitute the negative 3 for the variable, in this case the x. Going to square like we always do first. And then we're going to subtract, because that's what the order of operations says to do. And then, in this case, the square root of 4 is a perfect square number. It's a perfect square of 2. And so, that's how you deal with radicals, or radical functions.